Okay, so we just finished learning about mechanical energy. So how is it that we create or get this mechanical energy in the first place? The answer is that we do work on an object in order to create or transfer energy into this new object or system. So when the kinetic energy of an object changes, work has been done on the object. The units of work are joules, as it is the change in energy. Work is also just a scalar quantity, meaning that its direction does not matter. Work is just work, just like energy is energy. Work is going to depend upon the amount of force that is applied to the object, the distance that the object moves while the force is applied, and the direction of the force with respect to the direction the object moves. So although work is not a vector itself, the direction between the amount of force and the distance that it moves does matter. So if the force on an object is in the direction that the object moves, then the work done is equal to the force times the displacement. If the direction of the force is opposite the direction the object moves, then the work done is going to be equal to negative force times the displacement. Yes, we can have negative work done. This negative, however, is not an indication of direction, as work is a scalar quantity. In this case, our work done is showing that energy is being taken away from the system. Force is not work. If there is force being done on an object and the force is perpendicular to the direction the object moves, then the work done is zero. If the object doesn't move at all, then the work done is zero. So if I push on a wall, I can expend a lot of my energy within my own body, but because the wall doesn't move, I have done no work. So how does this work relate to kinetic energy and or mechanical energy? Well, the work done on an object by the net force is equal to the object's change in kinetic energy. In other words, as we apply positive work to a system, its change in kinetic energy will increase. As we apply negative work to a system, the object's change in kinetic energy will decrease. Sometimes work is not converted directly into kinetic energy, but rather just stored or hidden energy. For example, a man climbing up a ladder, the force that he is applying is downward and his displacement is upward. So he is actually doing work, and in this case, rather than increasing his kinetic energy, he is increasing his gravitational potential energy. So if we take a look at a couple of situations, work is just equal to the change in energy, and energy can be defined as just the ability to do work. So if we take a look at this tall man who decides to just lift the block straight up, he has to apply more force in order to lift this block up than the boy that's pushing the block up the incline. However, he has less distance that he is going to apply this force during. So this man is going to be lifting this block at a displacement of 3 meters. So his distance is 3 meters. It's going to take him 400 newtons to apply a force to lift this block. So taking our force times the displacement, both in the same direction, therefore positive, we get 1,200 joules of work. Or 1,200 joules is the change in energy. Taking a look at the boy that's pushing the block up the incline, he has much less work he has to do because he's not as strong. There's only 200 newtons of force being applied. Those 200 newtons of force are being applied in the direction of the displacement on the incline. Therefore, they're parallel to one another, both positive. And we see that that ends up being 1,200 joules of energy. Remember that a joule, 1 joule, is equal to a 1 newton times 1 meter. Or in other words, a force times a distance unit. For homework, gather all your notes together from energy as well as work. Bring your questions with you to next class. And when you come to next class, be ready to work.